السلام عليكم ورحمة الله وبركاته. This is Bushra Lehtera. I'm a SOC engineer at Sobrani Solutions. I'm going to present our B Armor as a tool to detect and prevent browser-in-the-browser attacks. This is the group members that we developed this product, which is the first automated solution. Bushra, Noor, Asma, Fajr, and Layan. We will go through the background of the browser-in-the-browser attacks. What is this attack? Then the problem statement. Then the B Armor workflow. Then the tools and functionalities. Lastly, the demo and the contribution and achievements of our product. Did you hear before about browser-in-the-browser attack? Okay, I will explain it briefly. Browser-in-the-browser attack, it's focused on the single sign-on when you are trying to log in a website and you have like a choice to choose the login with a Google, with a Facebook, with Apple. This is the single sign-on. All attack happens here in the pop-up window that's let you sign in with your email and a password. If you can see this pop-up, can you determine is it a fake one or a legitimate? What is the first thing that you are looking for in this browser? How can you investigate or indicate this is a phishing pop-up or it's an illegitimate? The link itself. Okay. Professional, we're saying you have to check the URL, as you said, it's correct. But here in this scenario, unfortunately, this attack appears the URL exact match as a legitimate one. So it's not working yet at all. It's an exact match. Even though you have, see here, the padlock image, which appears the SSL certificate, and all looks legitimate, right? How this happen? Professional, we're saying, see the URL, and it's not working yet. How this happen? This is all about an art. It's designed by JavaScript, CSS, HTML, so it's like an art designing the bar address, even though the body of the pop-up. So this is an illegitimate, it's a fake one, and you cannot differentiate between the legitimate and the fake one just by eyes. So how can we indicate it's a faking one? How can we figure out? Firstly, you have to interact with the padlock image. If you click in the padlock image and it's appears the information about the SSL certificate, so this is a legitimate one. If it's not an interactable, so it's loaded or inserted in the source code by the developer. So it's not generated by the SSL certificate authority, right? Secondly, you have to try to move this window pop-up out of the backend browser, the web page. If it goes out, it's good. If it's restricted in the web page, so it's not a legitimate one. As you can see here, this is the phishing one, and this is the real one. The URL is an exact match. There is no single difference between them. The logo is there, the padlock image. You can sign in, and all working fine. This is a demo, brief demo of the attack, as you can see here. The pop-up is restricted and cannot move out of the back web page. This is a real scenario that happens in the worldwide. It's used in Ukraine war, and also it's used in the Stream website that steals the credentials of the users. Let's now demonstrate our B Armor, which is the tool, and it's an Chrome extension that protect and prevent such kind of attack. Okay, how can we figure out? We said manually, right? We have to interact with it manually. If we are a professional, we can figure out. If we are not aware about it at all, we will fall on the attack for sure. So, the problem here, we have a browser-in-the-browser attack. No automation solution yet at all, and the current solution are working or doable in a manual way. This is how BArmor, our tool, works. When the user opens the web page, then BArmor starts working, scanning the indicators, then calculate the security percentage and give a percentage out of 100%. Then it will take the action. If it's okay, proceeds. If it's not, then can block or give an alert. This is the feature that we examine, how we can looking or find the indicators of this kinds of attacks. If there is an iframe in the code, iframe element, so this is the first indicator that the attack is there. Then we will check the URL that used an iframe with a total virus and other URL check. Then we will use going to use the machine learning and like for example, see all the images that inserted in the source code and see if it's in a padlock or not. If there is a padlock in the source image, so the code inserted manually in the code source, in the source code. If there is not, so it's good. Then compare the URL of the domain that used in the address bar with the URL that used in iframe. If it's match, good. If it's not, so this is a kind of attack. Lastly, check the validity of the SSL certificate. We use a lot of tools or a lot of language, programming language. For the front end, we use HTML, CSS, and JavaScript. For the backend, Python, Node.js, and the Django framework that's used for Python. So the final product is a Chrome extension that's used to install and used in the Google browser. This is the main function that we use. We have firstly the blacklist. We have our own blacklist. If any user used this tool before and it's figured out there is an attack in this website, so it will store it and this is a blacklist. So another user, when he tried to log in into the same browser, he will figure out this is a fake pop-up window. So it's not needed to go all over through the all functionalities and takes the time. Secondly, we will use total virus and check the URL and the SSL domain function. And lastly, with the machine learning and object detection to detect the padlock image. The testing result, alhamdulillah, our product is finally are ready to use. It's used and compatible with different OS system, Mac, Linux, OS, Windows. And it's tested with several websites. It worked properly. And lastly, it's deployed in the Google Store. So it's ready for individual usage. So what about the performance of our tool? There is four main efficient and accurate functions that we said before. Then we deployed it in the Google Cloud that embedded with a high CPU. And we are aiming to use a GPU for fasten the process. And it takes only 2 seconds in average to detect and prevent this such of attack. This is demo of our tool. You are trying to log in. We're using the Google service. As you can see here, you are trying to log in. The URL is exact match and all of it. This is a block via the extension that we use. If there is an detection before with other users, so it will fasten the process. If this is above the 90-100%. This is if it's under 90-100%, it will show just an alert. Alhamdulillah, we are the first automated solution that detect and prevent browser and browser attacks, and it's used in a real-time manner. So, alhamdulillah, this is the first product, Saudi made, or it's established in the Google store, and it's used for the individual users. This is our achievements. Alhamdulillah, we won the 10th place in Dell Technologies, that competition for the graduation project. And we are considered the top 20 in the cyberthon that was prepared by Munsha'at. And the third place at university for the best graduation project. Alhamdulillah, our product was selected by my company, which is Sobrani Solutions, to be commercialized and published and to be commercialized to the companies. This is our planning in the future. As you can see, we aim to provide this tool or the plugin for different browsers, not just for Google, and increasing the speed of detection by using a GPU instead of CPU, and add more features for detection models to enhance the efficiency. Lastly, publish a paper which will be considered the first paper that suggests a solution for such a kind of attack. This is all from my side. If there is any question, I can answer it.